Hi, I'm Mike Walsh. I'm the Director of Product Strategy for NetApp Modern Workplace. Today I'm going to be talking about the Virtual Desktop Service, which we use to provision virtual desktops in the public clouds, Azure, AWS, and Google Compute Platform, as well as private data centers and on-premise virtualization environments. I thought I'd start the presentation today with a quote from one of my favorite philosophers, Yogi Berra, because I think it describes the current work situation. Most of us used to go to the crowded place, the office, to perform our jobs. But many of us, because of the current medical situation, have been forced to work from home or an alternative remote work location. From a technology perspective, we need to support employees working from somewhere other than the office, give them access to the data and applications they need to perform their job. Virtual desktops are one of those solutions. In fact, ESG did a survey, and 71% of the IT organizations they talked to are either using a virtual desktop solution in 2020 or plan to deploy one over the next 12 months. Now that makes sense because we're not sure when the situation is going to change, which will allow many employees to return to the office to work. So we want a scalable solution that's both secure and gives the users the ability to perform their jobs from wherever they've chosen to work. At the same time, providing a virtual desktop environment to many employees can be a technology challenge. If we choose to do it on premises in a private data center, we have to acquire the equipment that we need to support the environment, compute resources, storage, networking, and similar components. Or if we choose the public cloud, we have to take all the raw services provided by the cloud providers and turn those into a virtual desktop environment. Both of these situations can incur a pretty high startup cost and occur ongoing costs as we support the environment from a staffing perspective. When we look at the IT skill set needed, we have to support users in a remote and virtual setting. That means that even if they have application challenges, session challenges, or need assistance, the administrators have to be able to work with end users wherever the end user is located, and for administrators that may be located several hundred miles away or even halfway around the world. Finally, we want to integrate these virtual desktops into the existing IT footprint. We want to extend the applications and data that employees need into the remote workspace, but we also want those to be secure environments. The virtual desktop service provides a solution to some of these challenges. I'll talk about the functionality in three major areas. The first is we need to deploy the virtual desktop setting. This requires us to deploy session servers, storage, network, security, and policy in order to create the environment. Virtual Desktop Service uses automation to perform all these tasks consistently and at scale. So the first machine that we use for a session server will look identical to the 100th or 1000th machine that we roll out. The second major area is the management of the virtual desktop environments. As I mentioned, we have to support users and their issues. Maybe they need access to new applications, or they need an application version upgraded, or they're having trouble with their session, or can't reach files and folders, or they're having performance issues downloading information to their local environment. Virtual Desktop Service provides both a web application and REST API endpoints to allow administrators to work with end users and manage their virtual desktop sessions from wherever the administrator is located. The third component is optimizing cloud resources. Now, when we deploy into a public cloud, we want to make sure users have a good experience. So we want the machines to be sized correctly, and we want to make sure that they have enough data to store all the application and data for their needs. At the same time, we don't want to over-provision the environment because typically with cloud vendors, we're paying per hour for the virtual machines, or we're paying per gigabyte for the capacity of storage. We want to make sure that while we want users to have a good experience, we also want to optimize the cost of the environment to match the actual needs. Virtual Desktop Service gives us a lot of flexibility where we choose to deploy virtual desktops. If we choose the Remote Desktop Service, we can deploy into Google Compute Platform, AWS, and Azure, as well as to any private environment, including data centers or on-prem virtualization environments that run the vSphere hypervisor. We can also choose to deploy VDS using the Windows Virtual Desktop technology that Microsoft recently introduced. Now that only runs on Azure, but VDS is capable of administering that and optimizing the environment for users of that platform. From a division of labor perspective, VDS handles the underlying infrastructure, the public clouds, their APIs, the hypervisors, and allows remote desktop administrators to focus on users, application, and data. They don't need to understand the underlying components because VDS will manage those for them. I don't want to spend a lot of time in a technology deep dive, but I did want to give you an idea of how VDS is constructed. From an administrative capability, the global control plane is a web application, a set of REST APIs, and a backing database that allows the administrator to execute provisioning and management tasks against the local environments. In turn, the local environments are managed by a control machine that works in the local Windows environment and provides the tool set necessary to administer applications, data, and policy. Now, in this situation, we're looking at a WVD deployment, and while Microsoft handles the routing, scaling, brokering, in other words, putting users on specific machines, as well as hosting the sessions, it's the VDS component's responsibility for managing the components when it comes to scaling the machines and accessing applications, data, and policy. We also wanted to take a quick look at some of the screens that are in the web application so you get a sense of how it actually works. When I'm looking at the workspace, I can drill down into the elements of that, the session servers, the applications, the folders and files that are stored in the workspace, and administer those right from the web application. The administrator also has access to jump on the machine using our connect to servers functionality that allows the machine to be accessed in a browser window. This gives administrators a familiar Windows toolset and working environment so they can administer the sessions. I should also point out that we can work with the chosen data layer. So in this case, we're using Azure NetApp files to support the virtual desktops, and the administrator can see the shares and the volumes required to support WVD. So some may ask, how does this compare to Citrix and Horizon, which are the traditional solutions that many companies have used on premises? Both Citrix and VMware Horizon have also created cloud components, Citrix Cloud and Horizon Cloud. So why should we use VDS instead of those solutions? There's several reasons. First, VDS uses the native components. Just one example, when we're talking about Azure Windows Virtual Desktop, it has native components for handling user sessions, for routing users, and providing user security. VDS simply configures those native components. Citrix and Horizon, on the other hand, use their own proprietary components that they've migrated from their on-prem solution into the clouds. VDS allows us to have the tight integration with the native components of each cloud vendor, especially when it comes to security and scale. The second reason is that we extend the automation using cloud APIs. VDS has a full REST API set, so it can be called from bigger orchestration or change control and governance systems that simply need to provision desktops. We can also use the VDS scripted events functionality to extend the automation and the workflows into customized scripts that are provided by the customer administrators. So for example, if we want to resize the user profile, we can write a script as an administrator, upload it into VDS, and then target certain machines to do that. The third reason is that we want to match the value of the license of VDS to the price for the functionality that we provide. VDS is priced per user per month and is appropriate for the chosen environment, whether it's the public clouds or the private data centers. Finally, VDS also provides savings when we're talking about optimizing the environment. Two examples of that. The first is if I have a number of users logging into session servers, VDS will automatically determine which servers should be on and which servers should be off. By doing an algorithm-based approach of matching the needed virtual session servers to the actual demand of user sessions, we save money by turning the machines off that we don't need. The second example is that the storage layer can vary in both capacity need, I need more space for more user files, as well as throughput. I typically need more throughput from the storage layer when users are logging in the morning or when they're saving data before they leave at night. VDS allows us to change the size and the scope of the storage layer to support both of those needs. The traditional solutions, Citrix and Horizon Cloud, typically don't. In addition, VDS can call on a number of NetApp cloud technology products to round out the rest of the virtual desktop environment. To name a couple, the storage layer, Azure NetApp Files in Azure, Cloud Volume Service in both AWS and Google Compute Platform, as well as the Cloud Volumes ONTAP solution that runs across all three clouds, gives us the capability to have a guaranteed throughput and capacity for the storage layer for virtual desktops. This is very important when we start looking at features like the user profile. When we start a virtual desktop session, we need that profile to come off the storage layer very quickly and get loaded into memory so that the session can start. If we have sluggish or congested performance off the storage layer, then the user session will suffer. Once we get past the storage layer, there's other tools to help us understand the environment. Cloud Insights collects data from a wide variety of sources, including the public cloud APIs, the VDS API, which can provide the context for sessions, applications, and servers, as well as the machines themselves. We can get the performance monitor data from any Windows device and send that to Cloud Insights. We can aggregate all of that information that's collected and form dashboards that help us understand the virtual environment. So we can see how a session's performing, how much an application is using in terms of CPU and RAM, and what the user is perceiving in terms of round-trip latency. Cloud Insights can also be used to set alerts if the environment is out of norm or above a threshold. Those notifications can be sent right to the administrators. When we look at the use of data, cloud compliance will allow us to enforce policy. Perhaps we're looking at GDPR regulations, or we're in a sensitive industry where financial information has to be protected. Cloud compliance can scan the storage layer for the virtual desktops and provide us information about where sensitive data is stored and which data is out of compliance with the rule set provided by the administrator. If you remember at the beginning, we talked about users that might move around between different locations. Global File Cache allows us to move their user profile with them, as well as give us access to very large files in the new location without having to wait for it to download from the original place. Cloud Backup Service gives us data protection on the data that's stored in the virtual desktop environment, whereas SaaS Backup for Microsoft 365 gives us a backup service for Word, Excel, Outlook, and Teams data that might live in the Microsoft cloud. While Microsoft will version that data, they don't provide a point-in-time backup and recovery service, so SaaS Backup fills that gap. Finally, the latest acquisition from Spot allows us to look at optimizing the compute side of the equation. As most virtual desktops are served up by a collection of session servers, Spot will allow us to vary the type of session server that we purchase. Sometimes we may need a pay-as-you-go server, while at other times it makes more sense to use reserved instances. And in some cases, we can actually use Spot instances that can be preempted on short notice. Spot has both the historical data and the artificial intelligence algorithms predict the best mix of those servers within our RDS collections, as well as our WVD host pools. Finally, just wanted to summarize the benefits of using VDS. We talked about how we save costs by making sure that we're only using the resources that we need. We can support regional implementations of virtual desktops, keeping them as close as possible to the end users. It provides a comprehensive tool set for supporting end users in the virtual environment. And finally, secures access for employees, regardless of where they're working from, into the important applications and data that are sensitive to the running of the business. In combination, Virtual Desktop Service is a comprehensive tool set, and especially when we combine it with the other NetApp Cloud products that allows us to provide a scalable, flexible, and secure virtual desktop environment. I'd like to thank you for listening today. For more information, you can go to cloud.netapp.com/virtual-desktop-service.